Hello, dear students. Welcome to the new lecture series on these complex analysis. Today's topic is that if we talk about that derivatives of analytic functions, right? So that means if we talk about the higher order derivatives of analytic functions. So how we differentiate, how you can make a distinction between this complex, if you take the derivative in the complex plane and if you take the derivative in the real calculus, right? So in real calculus, you can say that we cannot have higher derivatives or some function can have higher derivatives, but it's not necessary. But here, if you talk about these analytic functions, these complex functions, so these have higher order derivatives also, right? So I cannot show you the full derivation why from this. So how to calculate this derivatives, right? So this to calculate the derivative of this analytic function, so we can define that fn of z0 will be equal to and factorial divided by 2 pi r this, right? So that means this is basically when you calculate the derivative of a given function, right? Analytic function. Now let us do some problems on this. So how to use this, how to calculate the derivatives if we have some integral. You want to evolve with some kind of integral which includes the higher order derivatives, right? So one problem that I mentioned here. So we need to evaluate this integral. So this is the closed integral. This z plus 1 divided by z into z minus 3 into z minus 2 into z minus 4 whole cube, right? And where this c, so we can say here this c is a circle with that mod z minus 3 equal to 2. So that means from this it is clear. So that means, so we have this again a circle, but whose radius is 2. So ये हमें radius देगा. This will be the radius, and the center of that circle will be 3 and 0. Right? Because we have this real number, so it will lie on the real axis, but it will be on the positive side because when we write the equation of circle, that's x minus x naught ka whole square plus y minus y naught ka whole square equal to that r square, right? So where this x naught and y naught are basically the center of that circle, right? So but in our present case, our center it basically lies at a distance of at 3 on the real axis, right? But the y coordinate will be 0 because when you write that z in terms of that complex plane, so it will be x plus iota y, so it will be x minus 3. Right? So you can write that because if you write this as, so this you can write as that's x minus 3 plus iota y. So that's equal to, right? So इसको मैं ऐसे भी लिख सकता हूँ, right? You can take this will be x minus 3 का whole square plus y square equal to 2 square, right? So that is this our radius. So जो इसका radius है that are 2 units and whose center is that is 3 and 0. So 3 and 0 lies here. तो इसका जो center होगा circle का it will lie here. So this is the center of the circle because x equal to 3, right? It lies on the x-axis and y equal to 0, right? And the radius is 2, so it will be 2 units away from here. So better is to write this. So you can 1, 2. So this is the center, and it will be 2 units. So that means the radius of that circle will be 2 units, right? So this is the circle, and we need to integrate it over that closed circle. So that means this is our circle, right? And with the condition, and we have this kind of a function, right? So let us use that because you know that. So this, if you want to calculate the derivative, so you can use this formula to calculate to solve this integral, right? So before solving this integral, so let me revise some of the things. So first thing that is we need to check whether our function will be analytic. So first, if you check in the denominator, so first is that x equal to 0. The function is not analytic at z equal to 0 because it will be that 1 by 0 form. So that means it proves that z equal to 0 or z equal to 2 or z equal to 2. So in all these points, it will not be analytic. All these points, so function will not be analytic. So what will happen to first this r plus 1? Because so if its value, the value of this function will be 0, so it is definite value. But when we have that 1 divided by 0, like if you put that z equal to 0 or z equal to 2 or you put z equal to 4, so in all the cases, it will be some 1 by 0 form. So that means it is indeterminate form. Okay. So that means that's why I wrote here that z is 0 to 4 are basically at these points our function is not analytic. Okay. So now let's write now. Okay, let me write here. Our I will be equal to. Okay. Now first, so as I already told you, so it has, or you can say that it is not analytic, or you can say that it has singularity. So it has singularity at z equal to 2, z equal to 4, or you can say that in other words, so at these points, it has singularity, right? Because you cannot determine them. So because it will be some, you cannot define that function then. Because when you put that z equal to 0, z equal to, or z equal to 4, right? Now, or you can say that it is not analytic, or it is so singularity exists here for this function. Okay. So let us first solve this integral. So what will be f of z here? So if we go back to our function, so we have this kind of function, that is f of z. So in our present case, जो हमारा integral है, so our f of z is z plus 1, right? So that means our f of z equal to, that's equal to z plus 1. Now I need to add one more point. So if you talk about that, okay, first we can split it because we have three kinds of functions here. So it is cube here. Okay. So I can write this as, so this integral I can write as, so this I can write as closed integral that z minus 1. Okay. Or you can put this way. So this will be first. So when we check that at z equal to 2, right? So at z equal to 2, so it has singularity or it is not, the function will not be analytic, right? And plus, so first we put choose at z equal to 2, and similarly we can choose for z equal to 4 also, and then z equal to 0. So second is, if you put that closed integral that z plus 1 divided by, okay. Now, so this is, so these are two integrals. Similarly, I can put at z equal to 0. So that means that integral that z plus 1 okay. So what will be the first integral? So first integral is that when you put at z equal to 2, so this integral will be, so this will be simply that this will be equal to 2 pi I f of z at z equal to 2. So why I am writing this thing? Because, so just go back. So just check this integral. Okay. So our integral is n equal to 1 here, right? So n is equal to 1. So this is simply that f of z 0, that is 1 factorial divided by 2 pi I integral f of z dz divided by, that is z minus z naught ka whole square, right? Or you can write this as, so this will be 2 pi I f of z at z equal to 2, right? So this will be the first integral, and similarly second will be, that will be from here. So because we have that z minus 4 ka cube, so that will be equal to, that will be 2 pi I by 2 factorial. Why? Because this can be written as 2 plus 1, right? So this is 2 pi I by 2 factorial, and now okay, you write this thing. So this will be d3 d2 by dz2 just check here. तो यहाँ पे पहला इंटीग्रल हमारा ये है, राइट? So that was some f of z. तो f of z के बदले मैंने लिखा that is z plus 1 the whole thing, right? And first you check the analytic, because it is not analytic at z equal to, right? So you put that it will be that z minus 2. Okay. So you put in the so you can take that 2 pi I on the right hand side. So this will be then 2 pi I upon n factorial f of z n plus, right? तो अगर मैं यहाँ पे अगर यहाँ पे because our so you can have that z minus z naught, so it is z minus 2 here, right? So it is that function that z minus 2, so this will be equal to, so you can write this as and f n of so you write it this way, that is 2 pi I. That's it. Okay. So that means जो हमारा ये इंटीग्रल बनेगा, so this integral will be then 2 pi I, because it will be that one factorial, huh? f of z, so our f of z is this thing, and z equal to 2, right? So f of z is our this term, right? Because ये हमारा f of z है z plus 1 divided by z into z minus 4 and z equal to 2, and similarly इसके लिए जो हमारा f of z होगा that will be z plus 1 divided by z into z minus 2 and z equal to 4. So this is this thing, right? And similarly if we check this one, so this is at z equal to 0. So z equal to 0, let's have a look on this thing. So if you check, okay, okay, so what, okay, so this one. So at z equal to 0, so z equal to 0 is basically this one, this thing, right? So z equal to 0, it lies outside the loop, so it should lie within the domain. So our domain is basically this thing, right? So it basically lies outside that domain, so that means you can take that value equal to 0. So you cannot take that integral into account, right? So that's why the last one will be that will be equal to 0, right? So we have only these two integrals, right? So this will be equal to 2 pi I, and what's the f of z here? So f of z will be equal to, so f of z will be equal to that z plus 1 divided by z into z minus 4 cube at z equal to 2, right? And similarly this will be pi I. Okay, so why I'm putting this equal to, so this will be plus here, and this will be that d2 equal to 4, right? तो अगर हम यहाँ पे देखेंगे, बिकॉज यहाँ पे हम पुट कर रहे हैं z equal to 2, so you will get there 3 divided by 2 into minus 2 का cube, right? So this will be equal to, so the integral will be equal to, that is 2 pi I into, so that's minus 3 upon 16, okay, okay, and second integral will be that is pi I by 64 and 23 pi I. Sorry, so this term doesn't remain here, so we write it this way. So plus, that is 23 pi I by 60. So this is the value of this integral. So let us go back. So यहाँ पे मैंने क्या किया? You need to differentiate it twice. So using that rule, so you can differentiate this first, then twice, then you put z equal to 4. And the value of this integral comes out to be that's 23 pi I divided by 64. So this is how you can calculate such kind of problems while you have higher order derivatives. Otherwise, अगर यहाँ पे simply that z minus 4 होता है, तो अगर हम देखेंगे for example, okay, I will show you one more problem. So if we want to evaluate this integral, evaluate integral that tangent z bar dz upon, right? But remember here, so basically I did, so you just put here, so you put that f of z equal to z plus 1 divided by this all these things. Why? Because अब जरा यहाँ पे चेक करो, जो हमारा f of z था यहाँ पे in this one, so यहाँ पे मैंने जो f of z लिया, so मेरा f of z यहाँ पे था, that was z plus 1 divided by z into z minus 4. तो यहाँ पे मैं basically check कर रहा हूँ that the value at z equal to, so we'll keep that aside, so this is our total f of z. Similarly our f of z will be here, this thing, right? So f of z, ये it should not be indeterminate form, right? तो अगर मैं यहाँ पे z equal to 4, so you are getting some value. Similarly if you put z equal to, so you are getting some value, right? So that means our f of z will be whole this thing. So that is why, तो यहाँ पे मैंने put किया that f of z is equal to, that is z plus 1 divided by, depends upon हम किस पॉइंट पे देख रहे हैं. अगर हम z equal to 0 पे देख रहे हैं तो 2 हमें at z equal to 0 लेना है, तो skip this thing, rest z plus 1 divided by this term will be equal to, that will be our f of z. And similarly if you calculate for at this, that z plus 2, if you calculate at z equal to 2, so that f of z will be z plus 1 divided by z into z minus 4. So that means ये यहाँ पे रहेगा. Similarly at z minus 4, तो ये हमारा f of z रहेगा. Right? And similarly, so this is basically, so why we can use that higher order derivatives of analytic functions, right? And similarly, if you want to solve this problem, so this is somewhat, because if it will be simply, so instead of that, अगर यहाँ पे simply ये होता, so I can calculate directly. So using that Cauchy integral theorem, right? Or you can use this result because here our n is equal to, so that is equal to 0 here, right? So you can use that Cauchy integral theorem here, right? Instead of that, because so that is for n derivatives, because we have that fn of that z0 equal to that n factorial by 2 pi I and the whole integral, right? Now you can use that for this. You can also use that this higher order derivatives, because value of this n for this is that's equal to 0, because we have that in the denominator we have that z minus z not raised power that n plus 1, right? So that's clear. Now second thing is, instead of that, if you have the cube here, right? So again we will solve it, because if you put that z equal to 4, so z equal to 4, so function is not analytic. So that means if you at z equal to 4, function is not, right? Or you can say that it has singularity at z equal to 4, because at z equal to 4, so this becomes indeterminate, right? Or you can say that or it has, okay. So that means at z equal to 4, if you talk about, so it is some, so you can have this, this is simply that we have, so you need to integrate this equation, right? So you use this nth order derivative of this using that nth order derivative of these analytic functions. So because we have that fn of that z0, so that's equal to n factorial upon 2 pi I goes to integral, that's f of z dz is for f plus, right? So that means जो हमारा f of z यहाँ पे है, so f of z is our, that is tangent of z, right? So that means I can write, now this I can rewrite as, so this integral I can write as that's I equal to, that is okay. So this I can write as, right? So that means and जो हमारा that's 2, right? So n is 2, right? So using that this integral term, so for this, so you can write that, so I will be equal to, that will be equal to 2 pi I upon 2 factorial, because you just check that, तो इसको मैं लिख सकता हूँ 2 pi I में यहाँ पे लूँगा, that's fn of 0 by n factorial this, right? So that means, so this will be equal to 2 pi I by 2 factorial, and what's our, so because our n is equal to 2, so it will be then, right? And then tangent of at z equal to, okay. So first you differentiate this, so you will get here that's pi I, and if you take the differentiation, so tan theta it is sec square theta, and sec square theta again you differentiate, that is twice sec square theta tan theta, right? So this will be equal to twice sec square z tangent of z equal to pi. Okay, so this will be equal to 2 pi I, and what is sec square pi by 4? So this will be equal to, it will be equal to 2 into 1, because you can write that 1 by cos square, that cos square z, that is pi by 4, right? So cos 45, that's 1 by root 2. You need to take square of that, so it will be 2. So 2 is here, and similarly tangent of that's pi by 4, that's 1, right? So this will be equal to 4 pi, right? So this is the value of, so how you can solve these integrals in a complex plane for higher order integrals, right? And similarly, in our coming lectures, we will talk about these Taylor series. So this is one of the finest application of that Cauchy integral theorem, and we will use it for some of these functions and this construct those these Taylor series from this Cauchy integral theorem. So that is our next topic. That is the application of that Cauchy integral theorem. So which is our that Taylor series expansion. Okay, thank you.